Hello students, so this is the second subtopic of second unit in IB Diploma Chemistry. The objectives: to differentiate between the shapes of atomic orbitals of S and P, to apply Hund's, Pauli's exclusion principle and Aufbau rule to write the electronic configuration, to differentiate between electromagnetic spectrum, to differentiate between absorption and emission spectrum, to differentiate between line and continuous spectrum. What do you need to take care during this subtopic? Like you can find the electronic or electromagnetic spectrum with wavelengths in data booklet in section 3. Students need not to know the names of Lyman, Balmer, Paschen, etc. series in hydrogen spectrum. Students should learn condensed, full as well as orbital diagrams of electronic configuration. You should also know the exceptional cases of copper and chromium, like while doing the electronic configuration. The TOK in this subtopic: we know that new discoveries are overshadowed the old one. We should think that why should theories be considered as knowledge at a particular time if it is changing with time? So this is a TOK question. Nature of science: we know the new theories or discoveries are replacing old one. Thus improvement in both knowledge and technology is happening continuously. The improvements from Thomson's model to Rutherford's to Bohr's to modern quantum mechanical model is an evidence of positive scientific development. The keywords during this subtopic is like they are electron configuration, quantum, uncertainty, orbitals, momentum, probability, wave, Aufbau, node, etc. These are the keywords. So starting with quantum mechanical model. So what is this? So this model is based on Heisenberg's uncertainty principle and Schrödinger's equation. This model helps to understand the electronic structure of an atom more precisely. So the other theories also, other models also tried to explain that, but here we can understand it more precisely. It explains the address of an electron inside an atom in the form of quantum numbers. Heisenberg's uncertainty principle: to know that, first of all, so Heisenberg suggested that it is impossible to determine momentum and position of an electron in an atom simultaneously. So if we want to determine momentum, we can't determine the position. So both these two together we cannot do that. Okay. If position is to determine, its momentum will change, and vice versa, because light or energy is to be dropped on an electron to track it, which will change the position of the electron, because the electron will absorb that energy and then electron will jump. Momentum: what is momentum? Momentum equals to mass times velocity. Hence, if it is not possible to determine the position of an electron, how can we say that electron revolve around the nucleus in discrete orbits as suggested by Bohr? We can only find the probability of electron in some space, and we call that space as orbital. So we cannot say that electron revolve around the nucleus in discrete orbit. So they are not in discrete orbit because we are not sure whether they are there or not, because we cannot determine them. We cannot certainly say that they are there in that particular. We can only say probable percentage, like probably 90% they are in this particular region, and that place where, or that space where the electrons can probably be found, we call them orbitals. Next is, what is Schrödinger wave equation? So Erwin Schrödinger gave a mathematical equation, Schrödinger wave equation, for the wave nature of electron. You know, you have already learned the wave nature or particle nature. So this is about wave nature of electron, and he gave this equation H psi equals to E psi, where H is Hamiltonian operator and E is the total energy operator. Solution of this equation using supercomputer gives numerical solutions which we call as quantum numbers. though we do not need to know them, but it will be helping us to determine whether which cell has which subcells, and if it is possible to have a particular cell, particular subcell in a particular cell. Like for example, is it possible to have 2D? So that is not possible, but it will be more easier when we know the quantum numbers. So first one is principal quantum number. So principal quantum number is denoted by small n, and it tells us about the energy and distance of an electron from the nucleus. So for example here, so this is the electron, for example, so distance from the nucleus. So how far the electron is, so that is given by principal quantum number. So far we have 7 periods in the periodic table. This is very important information I am providing you. So we have 7 period in periodic table, hence 7 energy levels. So you can correlate why there are 7 period, because 7 energy levels. So that means we can relate energy level with the period of the periodic table. So each energy level is related to each period in the periodic table. So you can better understand and correlate periodic table with this quantum number. So these cells can also be designated as K, L, M, N, O, P, Q, etc. So like that, or first, second, third, fourth, fifth, sixth, 7, 8, like that. Second quantum number is azimuthal quantum number. It is denoted by small l, and its value depends on principal quantum number small n. It tells us about sublevel of a cell, that is subshell. So for each value of n, L is equal to 0 to n minus 1. So n is equal to 1 means L equals to 0, means S subshell. N equals to 2 means L equals to 0 and 1, means S and P subshell. N is equal to 3 means L equals to 0, 1, 2, means S, P and D subshell. N equals to 4 means L equals to 0, 1, 2, 3, means S, P, D and F subshell. So like that. So that means L depends on N, and L equals to 0 to N minus 1. 0 to N minus 1, all that. Okay. So L value always 1 less than N. That means to have D subshell, we must have minimum 3 shells. It means I was asking you, 2D is possible? No, it is not possible, because for having D subshell, you must have how many shells? Minimum 3 shells. So that is what we need to understand. Shapes of atomic orbitals. Mainly shapes of atomic orbitals of shells include S orbitals and P orbitals. Here in IB we only need to know S and P orbitals. S orbitals are spherical in shape. They are concentric, which means one orbital into another. So as I shown you this diagram, so this is one cell into another. So S orbitals, they are concentric, like 1s, 2s, 3s, 4s, they are one into another. Node is the space between two orbitals where electrons probability is 0. So there in this region, node region, 0 electrons are there, 0 probability. Okay. Just for understanding, the white circular space between spheres is node. Here the one which you see, this is like node. It means 0 probability of finding electron. P orbitals have 2 lobes, like this one and one, like a English letter 8 or English number 8 shape. The electrons probability is only within the space of lobes, because nodes do not have any electron probability. That means here no electron, only electrons are into this lobes. So I hope this is clear. Next comes magnetic quantum number. It is denoted by small m, and it tells us about the orbitals. Each value of m corresponds to one orbital. For each value of L, m equals to minus L to plus L on number line. So we can say m depends on L and L depends on n. So m value is minus L to plus L through 0, and L value depends on n. So L value is 0 to n minus 1. So that's how they are interlinked. So if L equals to 0 means M equals to 0, means only one value, means one orbital. So one value of M means one orbital. So S subshell has only one orbital. That's we get out of this. Next is spin quantum number. It is denoted by small s and has two values for each value of M. +1 by 2 clockwise spin and -1 by 2 anti-clockwise spin. So which means 2 electrons. So maximum 2 electrons in one orbital, one clockwise and one anti-clockwise we get. So to summarize it, for principal quantum number 1, azimuthal quantum number will be 0 because n minus 1. And if L is equal to 0, that means S subshell. And because M value depends on L and L is 0, so M is also 0. And each value of M has 2 electrons. That is why it here written as 2. We can say one clockwise and one anti-clockwise. So 2 opposite spins. When principal quantum number 2, so we have two values of L, 0 and 1. Why 0 and 1? Why not 2? Because it is n minus 1. So 0 and n minus 1 is 1. 2 minus 1 is 1. And L equals to 0, we have seen already S subshell. L equals to 1 means P subshell. Similarly, L equals to 2 means D subshell. L equals to 3 means F subshell. So L equals to 0, S subshell. L equals to 1, P subshell. L equals to 2, D subshell. L equals to 3, F subshell. Okay. And that is the relation with electrons. So we can see each orbital 2 electrons, and that is why we count the number of orbitals together and we get the total number of electrons, maximum electrons. Now main rule here starts for electronic configuration. First is Hund's rule of maximum multiplicity. So what does it suggest? So it suggests that pairing of electrons does not take place until all the orbitals of a subshell are singly filled. So we need to have one electron in each orbital before pairing it into the orbitals. Second is Pauli's exclusion principle for electronic configuration. So it suggests that no two electrons can have same set of 4 quantum numbers. It means that an orbital can only have 2 electrons. This principle is used to write the orbital diagram of atoms along with Hund's rule of maximum multiplicity and Aufbau rule. So these two rules, we need to remember: no pairing until all the orbitals are singly filled, and in one orbital only 2 electrons. If third electron will be there, it will be of same spin, and that is not possible. What is Aufbau rule? So as name suggests, Aufbau is looks like it's a name of a scientist, but it is not. So it means building up. So Aufbau principle and filling of electrons in orbitals and subshells. So Aufbau principle for electronic configuration is not on the name of any scientist as usually happened in sciences. Aufbau means building up. Electrons are built up in orbitals of different subshells of different energy levels on the basis of energy. Electrons first fill lower energy level and then move to next higher level. So electrons start filling from 1s orbital onwards in the following sequence. So this is 1s, 2s, 2p, 3s, 3p, 4s. Why not 3d? Because 4s has lower energy than 3d. That is why it is based on energy levels. I summarized it in this way: SSP, SPS, DPS, DPS, FDPS, FDPS. This can build up entire periodic table. So you only need to remember SSP, SPS, DPS, DPS, FDPS, FDPS, and that makes whole periodic table. I told you that this 4s has lower energy than 3d, that is why it comes first. So that you need to take care. So 1s, 2s, 2p, 3s, 3p, 4s. So like that it will automatically, you can fill up this. So this is a short form. SSP, SPS, DPS, DPS, FDPS, FDPS. So how it will be? 1s, 2s, 2p, 3s, 3p, 3d, 4s, 4p, 4d, 4f, like that. But the filling is not the same way. So this is the Aufbau diagram. So first electron enter into 1s, second electron also enter into 1s. Why it is so? Because S subshell can accommodate 2 electron, P subshell can accommodate maximum 6 electron, D subshell can accommodate 10 electron, and F subshell can accommodate 14 electrons. So that is why first 2 electron enter into 1s and then it goes to 2s. So 2 more electron in 2s and then 6 electron in P subshell 2p, and then it goes to 3s, to 3p, to 4s. Then did you see the sequence? S, SP, SPS, and then 3D, 4P, 5S. So it becomes DPS, and then again DPS, and then FDPS, FDPS. That is why I have given you the short form SSP, SPS, DPS, DPS, FDPS, FDPS. So like that. Now I'll show you how to draw this as well as draw the electronic configuration. So we start with 1s, then 2s, then 3s, then 4s, then 5s, then 6s, then 7s, then 8s. So these are S subshell. Then we know P starts from second shell. So we write 2p, then 3p, then 4p, then 5p, then 6p, then 7p. And we know D starts only in third cell, so it is 3d, then 4d, then 5d, then 6d. Then we know F starts only at fourth, so 4f, then 5f. Okay, so like that. Now you can see what the sequence is coming. So now we will take up the example. For example, you want to write the electronic configuration of carbon. Atomic number is 6. So what the sequence I told you? So 1s, and we know maximum 2 electron can come. So 1s2. Second comes 2s. So 2s2. So total 4 electron. Now still 2 more electrons are there. So SSP. So 2p is there. And we know how many electrons are remaining? 2. So together they are 6 electrons. So this is the electronic configuration of carbon. So total 6 electron. Now if we want to write it the orbital diagram, then it is opposite spin, 2 electron. This is 1s. 2 electron in 2s, opposite spin. And in P subshell, now you need to remember the pairing cannot take place until all the orbitals are singly filled. So we need to put 1 electron here and 1 electron here, like that. So 2p has 2 electron. So if we write the electronic configuration like this, there is no need to worry. But if we are asked to write the orbital diagram, then we have to write this way. Each orbital 1 electron in P subshell. Moving further, if suppose we want to write electronic configuration for sodium, atomic number is 11. So it will be 1s2, 2s2, 2p6, then 3s2. Is it 3s2? No, you count, it becomes 10 here. And how many are there? So it is not 2 but 1. If we write magnesium, magnesium is 12. Then instead of 3s1, it will be 3s2, and rest it will be the same. Okay, so I hope you are getting it. Similarly, I'll write it more. So we say atomic number 24. It is chromium, the exceptional case. Now you can see how I write it. So 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, and 3d4. So you can see count 2 and 2 4 and 6 10 and 2 12 and 6 18 and 2 20 and 24. So it seems like correct according to the sequence SSP, SPS, D. So it is coming the sequence, but what exception I told you, wherever D4 is there, it is need to be changed into D5. So this D4 need to be changed into D5. For that, what we need to do, we need to take one electron from here and put it here in D4 to make it D5. So what will be the new configuration for this? So it will be 1s2, 2s2, 2p6, 3s2, 3p6, 4s1 and 3d5. So 4s1 and 3d5. This is in case of chromium. I hope this makes sense. Why it is so? Because d subshell has 5 orbitals and each orbital can have 2 electrons. This is one second orbital, third, 4 and 5. So each orbital can have 2 maximum. So this is d maximum electrons, but in this case there are 5, so it means only 5 electron that is in each. I hope this makes sense. So d subshell can maximum as 10 electron because there are 5 orbitals, but in this case it is only one electron in the d orbitals. So it will be, actually it will be like this. So 1 electron, second electron, third, fourth and fifth. So if you look this 3d5 and if I compare it with 3d4, so if you see this 1, 2, 3 and 4, which one is more symmetric? So you find this is more symmetric because it is exactly half filled. That is why 3d5 is considered as more stable configuration in case of chromium. So this is exceptional case. If we look another exceptional case, that is atomic number 29 and that is copper. So if we write the electronic configuration, so 1s2, 2s2, 2p6, so it becomes ssp. Then sps, 3s2, 3p6, 4s2 and 3d9. So this is 10 and this is 10 and 9, 29. But what is there? As we discussed, D9 need to be changed into D10 for stability. That is why this 1 electron goes here and it becomes 4s1 and 3d10, more stable configuration. So that's how you need to do, otherwise there is no change. So I hope this makes sense to you and you can easily write the electronic configuration provided you know the sequence SSP, SPS, DPS, DPS, FDPS and FDPS. A whole periodic table will comes under this SSP, SPS, DPS, DPS, FDPS, FDPS. Thank you guys and girls.